Hi, you are warmly welcome to today's lesson on this channel, my YouTube tutorials. Now, I've been thinking about the current name of the channel recently, and because of the kind of lesson that I deliver here, I think the current name doesn't really suit the channel. So, my viewers who want to give the channel a much well-deserving name, drop the name in the comment section down below and let's rebrand the channel together. Now, if you had followed or if you have viewed my previous lesson or my previous video that I did, then you knew that we started a topic in core maths 2 weeks back. We'll be visiting the same topic today, and that topic is statistic 1. Now, we'll be concentrating more specifically on statistical dispersion. I go by the name Mr. Derek Ahiamble Edem. Think about this scenario. You went to class and the teacher walked to the board and wrote on the board statistical dispersion. What the hell is all this going to be about? That's what you might say, right? Well, worry not. Because when we talk about statistical dispersion, in statistics, it deals with the extent to which a distribution is stretched or squeezed. That might sound simple, right? Hell no, it involves a lot more than that. I'm no statistician, but in this lesson, we'll be looking at deviation, standard deviation, the range, and the interquartile range. But considering how long this lesson might be, I'll do the interquartile range and the range in a different video, in the next video. Are you intrigued? Let's quickly look at the deviation. Deviation in mathematics is a measure of the difference between the observed value and the mean of the observed value. The observed value we are talking about here is the observation that is represented by x, and we represent the mean by the x bar. Are you a formula person? If yes, then this is your part. All that I said earlier about the deviation can be represented simply or mathematically as deviation equals x minus s bar, whereby our s here is talking about the observed value and the x bar is talking about the mean. What this means is that we are just subtracting the mean from our observation to get the deviation. Now, in all the questions that I've solved before, none of them has ever asked me to find the deviation on its own. So because of that, we won't be talking about, or we won't be looking at any example on it. But when we go to standard deviation, we'll take all of them together and look at them. Let's look at how best we can calculate the deviation. So how to calculate the deviation of a set of numbers. Now I'll be listing a strategy by which when you go by them, you just, with the strategy, you just calculate the deviation. Now the first thing to look out for is that from the set of numbers, calculate the mean of the individual numbers. I mentioned individual numbers because when we are looking at statistic, we are looking at data. Data has been given to us, or data that we have collected. Maybe we collect a data on mark obtained by students. So those marks, they are our observation. They are our individual observation. Now, we are taking them one by one and we are calculating the deviation of each of them. So we are going to calculate the mean of the individual numbers. Let's say we have 3, we'll calculate the mean of 3. We have 4, we'll calculate the mean of 4. And then we'll proceed with that. The next point is to subtract the mean that we have calculated, the mean of each number from the corresponding number, and that number is the x, which I'm talking about as the deviation, as our observation. So with that all said, let's proceed and look at the standard deviation. Now this work, standard deviation, is so broad. There is standard deviation in mathematics, and there is also standard deviation in chemistry, and that too with its own unique formula. I am not going into that of chemistry, so let us stick to what we are doing. Standard deviation is the measure of the amount of dispersion of a set of values. What standard deviation does is that it limits mathematical error. Now, when mathematicians are working, they want to work with high precision. They want to work and get high quality numbers that they can relate to, because when we are dealing with statistics, mostly we look at it from the business point of view. So because of that, we are dealing with numbers. So you have to obtain numbers that have high precision. So you have to limit your errors, and because of that, standard deviation helps you to limit your errors. Mathematically, standard deviation equals the square root of the summation of the square of the deviation of the individual observations divided by n, where the symbol that we have here is the sum of the deviation of the individual observation from the mean, all squared. What this means is that we are dealing with the deviation for each of the observations. Now I'll be explaining that very soon, so you will soon understand what I'm talking about. But what we are dealing here, keep in mind that we are dealing with each number. So that's why we are having the summation. This symbol here is talking about the summation, and this is the deviation. The D here is the deviation, and we have the square of the deviation, and we are adding the square of the deviation of all the observations. Now, our n is the number of observations, and that is what we will divide over here. This thing here is the square root sign of this mathematical formula. We'll be taking an in-depth look into the formula to help understand it better. With that being said, let us quickly divert our attention to all the steps in calculating the standard deviation. And over here, we'll be looking at the step to follow to calculate the standard deviation, because when you look at the formula and you just want to go into the calculation, you'll be confused. Let me tell you the truth, because you need to relate the things before you can get a standard deviation. Now, when you are calculating the standard deviation too, you represent the data that has been given to you on a table. That is because first you are calculating the mean of each of the observation. You get it right? You are calculating the mean of each of the observation. Now, from that mean, you are also going to calculate the deviation of all the numbers of all the observation, and you calculate the square of it. So you cannot just write it anywhere and think you are doing it. After all, you are going to find the summation of the square of the deviation. So you can see how complex it is, right? So because of that, you are going to represent it on a table in a way that anybody who take your work can understand what you are doing. So because of that, we are going to look at the steps in calculating the standard deviation. The first thing that you have to look at over here is to calculate and record the mean of the individual set of numbers. That is not all. Next is to calculate and record the absolute value of the deviation of the individual set of numbers. The absolute value they are talking about, or we are talking about here, is or are positive values of the deviation. Now, what that means is that we are only going to record the positive values of the deviation, because look at this. When you calculate the deviation, you might get negative if the mean is greater than your observation or the observation that you are looking at. So because of that, we are only looking at only absolute values with positive numbers with positive value. So that is why we are recording. After recording the absolute value, next is to calculate and record the square of the deviation of each set of number. You calculate and record the square of the deviation of each set of numbers. So you'll be squaring your absolute values that you've seen over here of the deviation that you've gotten or you've derived from this calculation as step 2. You use them or you square them to get the square of the deviation of each of the number, and you record them accordingly. Now, a closer look at the formula of the standard deviation provides an indication that we need to find the summation of the square of the deviation. Hence, you have to add the square of the deviation. That is, you are finding the summation of the square of the deviation. Finally, using the formula for the standard deviation, calculate the standard deviation. Now, with all this being said, the only thing left is that we need a table to sum all of this up. So, here is that table that we need. Now, this table is what we will construct if we are given any question to find the standard deviation. Most importantly, we are looking for the standard deviation. Now, over here, you can see that everything that I talked about on the previous slide is represented on the table. We have our mark, which is our observation, depending on what the question gives you. That is what will be at this first column. And we have our mean over here, and you can see that we can calculate the mean of each of the observations. So let's say that we have some numbers over here. Sorry, I don't have any number, but I believe you understand. Then this is our deviation, and we are finding absolute values. Absolute value, you record only positive numbers, and then we'll find the square of these absolute values. Now at this place, we are finding the summation of the square of this deviation. With the table, I believe you really understand everything that I said about. Now, if you are new to this channel, please subscribe to my channel so that you will get notified when I upload more educational and interesting content. Thank you very much for watching.